this problem has a lot of pieces in order to figure out what's going to happen. So I go through and label things, and let's think as we go. So I have a volume, and then I see that I have a gas mixture. And when I have a gas mixture, that means that partial pressures might be involved. And I have a couple of equations I might think about. One is Dalton's law. The total pressure of the mixture, and this would be the total pressure of the mixture, is equal to the partial pressures of each of the components. So we have nitrogen and gaseous water, water vapor. Okay, so I might use that. Again, the mixture, that's the total pressure. I have a temperature, kind of note it's in Celsius. I have one of the partial pressures. And then I'm asked for the mass, so that's grams, of nitrogen. And remember, if we know what the gas is, I'm interested in nitrogen here. That means I can figure out a molar mass, and that gives me a way to get from moles in to grams. And so if I could get to moles, that would give me one more step to get to mass. Okay, well, I don't have any 1s and 2s, so I don't have like a before and after combined gas law. Let's see what I have. PV, I have the couple pressures, but if you look, those are related to this. And so from that, I could get the partial pressure of nitrogen from that. Well, let's look. Another main equation that I know is this one. And it seems like I have a lot for that. So I have a volume. And this volume, it is a mixture, but it is the same volume for the nitrogen as it is for the water, as it is for the mixture. So I have the volume. I have a temperature, R we know. I would love to get in, that's moles. And then for the pressure, I need to be careful because this is a mixture. So instead of using the total pressure, I need to make sure I use the pressure of nitrogen. And if I use the pressure of nitrogen, the partial pressure of nitrogen, then this moles will be moles of just nitrogen. If I had put in the total pressure here, then I saw for moles, the moles would be total. It would be nitrogen and water. But if I use this partial pressure of nitrogen, then, so a lot of steps to this one. First, I can get my partial pressure of nitrogen, and then I can use this to get to moles of nitrogen, and then I can use my molar mass to get to grams of nitrogen. So let's think about, let's just start with our partial pressure of nitrogen. So this is Dalton's law. And for this, it doesn't matter what the units are as long as they match. Okay, so I have a partial pressure of nitrogen, and I said I would use that. So this is my first step here. And now I'm going to go to the second step here. Okay, and when we do this, remember this equation has R, so I really have to watch my units. And I notice that this pressure is not in the correct units. I'm going to convert that to atmospheres. Carry an extra digit there. Really just has 3 sig figs. Remember the 760 is exact, or we treat it exact, so 3 sig figs there. I really have 3 sig figs. I need to also watch my temperature. Now I'm ready to plug in. I've got the correct units for everything. Then I'm going to divide. I'm basically dividing both sides by all of this. And we know all of that would cancel when I divide by all of that. So on this side, I see that my liters cancel, my atmospheres cancel, my K cancels, and I'll be left with moles on the denominator of the denominator, which means that's the same thing as it being on top. Okay, I have my moles. So the last step I said that it asks for grams, but if I have moles and I know the molar mass, I can get to grams. So this is our step 3. And to 3 sig figs, this is what I get.